Assalamu alaikum, my name is Sami HADDADJI from Al School for Boys. Today I'll be presenting our submission for the Net Zero Challenge. I'll start off by giving a small introduction about ourselves. We currently study in Al School for Boys in the 11th grade. We study in the science track, aiming to pursue engineering in the future. CO2 sources at our school. What are the main contributors towards the high CO2 emissions in our school? The main contributors towards the high CO2 emissions in our school are direct CO2 emissions and indirect CO2 emissions. What are direct CO2 emissions? Direct CO2 emissions are the emissions that are resulting from the consumption or burning of fossil fuels, such as diesel and petrol, which are required for the transportation of students, school staff, and the supply of food to the school canteen. Indirect CO2 emissions are a result of electricity consumption in the school, such as air conditioning, lights, computers, and many other electric devices. Climate change and net zero. Why are the high CO2 emissions in our school a problem? The high CO2 emissions in our school are a problem because they will contribute to the overall CO2 emissions in the UAE, which will increase the effects of climate change and global warming. What is climate change? Climate change is about the abnormal variations to the climate and the effects of these variations on other parts of the Earth. It is caused by the increase of CO2 concentrations in the atmosphere. What do you mean by net zero? Net zero refers to the cutting of greenhouse gas emissions to as close to zero as possible, without any of the emissions being reabsorbed. This can be done in many ways, such as transitioning to renewable energy and adopting sustainable practices. Net zero plays a crucial role in combating climate change and aiming to make a more sustainable future for the coming generations. Our solution. Our solution to lowering the CO2 emissions in Al-Nahda is to build direct air capture technologies around the playground from above, to capture CO2 from the air and store it underground. How does our solution work? Direct air capture technologies capture carbon dioxide directly from the air. Air passes through the DAC system. Then CO2 gets separated by chemical process. Using high-powered fans, air is drawn into a processing facility where CO2 is separated through a series of chemical reactions. Then the CO2 is either permanently stored in underground reservoirs through secure geological sequestration, or is used to make new products such as building materials and low-carbon fuels. To make our solution effective, we have to use clean power, which is produced from renewable energy or nuclear energy, to minimize the carbon footprint. One of the main technologies for direct air capture is developed by a company called 1.5, which have developed a larger scale DAC solution in Canada, which uses a chemical solution to absorb CO2 from the atmosphere. Our solution is split into two parts. The first part is a giant fan pulls air into the air contractor, where it passes over thin plastic surfaces that have potassium hydroxide solution flowing over them. This solution chemically binds with the CO2 molecules, removing them from the air and trapping them in the liquid solution as carbonate salt. The second part is the CO2 contained in this carbonate solution is then put through a series of chemical processes to increase its concentration, purify, and compress it, so it can be delivered in a gas form ready for use or storage. This involves separating the salt from the solution into small pellets in a structure called pellet reactor. These pellets are then heated in a third step, a calciner. In order to release the CO2 in pure gas form, this step also leaves behind processed pellets that are hydrated in a slaker and recycled back within the system to reproduce the original capture chemical. Once pure CO2 is produced, it will be compressed using large compressors. Then, it will be transported through long pipelines for the final underground storage. Old depleted oil and gas reservoirs can be used as a storage location where CO2 is sequestered forever. Why will our solution be effective? Our solution will be effective because it has no limit to capturing CO2, and we can capture as much CO2 as we want in any location, and there is no limit to storing the CO2 underground. As Antoine de Saint said, a goal without a plan is just a wish. Thank you for listening.